Hey, welcome to the channel, guys. We're gonna do our little PMA experiment here. See if we can turn this stock alternator out of a 2010 Pontiac G6. We're gonna pry this plastic off. Oh, broke it. That's all right. I don't think we're gonna need it again. Anyways, 2010 Pontiac G6 with a 2.4 is what this thing came out of. I don't even know if the alternator is any good, so, but there's the part number. It's says 14 volt at 120 amps. So, but we're gonna try and run it at 48 volt. We'll see. We're gonna get rid of the voltage regulator and all that stuff, but I'll explain that when we get into it. I've never messed with one of these particular alternators, but it's actually pretty handy because your three-phase AC is right here. All your alternators are three-phase AC until they go through the bridge rectifier. So the bridge rectifier steps it down to steps it over to DC. And all the nuts here are 7mm on this particular part. Now these four, there's four altogether. Those are 8mm. So 7 and 8mm is all you're really going to need to get this thing apart. Possibly a set of wire cutters, because the voltage regulator or the bridge rectifier is right here. And then we got to get rid of the brushes and some other things here to make it put out AC power. And then we'll re-rectify it to our 48 volt. Now we won't be able to use this rectifier, I don't think, but maybe. I have full bridge rectifiers anyways for my wind turbines, because they put out three-phase AC as well. So we'll get this torn apart here. Nothing exciting happening yet. Now, in the past, I used neodymium, I think that's how you say it, rare earth magnets. I bought them on Amazon or eBay, one of the two. And I had to do a ton of machine work to the rotor to get them to fit inside. And the problem I had doing that was it would always, at high RPM, no matter what I did to connect those magnets, man, it would sling them right off there. Now, I should have probably encased it in an epoxy resin and then machined the epoxy resin back down to fit. But the tolerances are so tight inside there that it ended up hitting the stator. Well, I got the other one right here. Here's my first attempt. Now, for some reason, I lost the rotor, but you can see where it ended up, the magnet slung out and started rubbing the stator. I don't know if you can see that in there or not. The wear marks along this edge. Yeah, so, I mean, it did pretty well as far as power output. I didn't think it was very good at the time, but then once oh, well, that's handy. That gets rid of the brushes and everything all in one shot. Nice. A lot easier than the other one I messed with. So what we have left here, I would imagine, is just the rectifier. Like I said, I've never actually messed with this particular style alternator. Something's holding it. Well, whatever it is, we're either breaking it or it's coming apart, one of the two. Now, that's probably the voltage regulator. Yep, I'd say so. There's all kinds of wires here. I'm gonna get some cutters. I'm just gonna snip those off. And we can just completely ruin this alternator. I don't know, but it doesn't matter. This is experimental. I do have another alternator over there that's more traditional style. And I'll leave those wires long just in case we need to hook to them for any reason, but I don't think so. Okay. Well, we do need to hook to those wires because those come right off the 3-phase. My chickens are in the garage. They come in here all the time, man. They just love me, you know. All right, well, I don't know how we're going to cut that out there cleanly. My chickens are wandering over here. The rooster's outside calling for his ladies, wondering where the heck they went. They're in here bothering me. Yeah, so this is the rectifier, I would imagine. I'm going to try and just nip that out there. Oh, that seems to be working. There we go. All right, so now we're going to pull the 8mm bolts and see if we can slide this right off of here. Probably won't be that easy. The bearing will either be stuck on the shaft. And before I go too much further, I am going to mark that just so I know how that lined up. Nothing fancy, just a marker. And we'll just color this side. And then color this below this screw, just so we know where it goes. Just to be safe, we want to put it back together the way we took it apart, you know. That was one of the other problems I had with that, my first attempt. I had it apart and together so many times that I ended up stripping the threads out of the housing, so. And we'll just set all the bolts over there so they can roll away and get lost. And then we'll see if this housing will come apart. I'm going to gently persuade it. You don't want to crack the housing. They're pretty fragile, surprisingly. I broke a couple spindles, or, you know, these cooling ports, I guess you'd call them, on the other one when I was messing with it. And see, the problem is this bearing is probably pressed onto that shaft. Oh, looks like it might be coming. Yeah, she's coming. But you want to be gentle and work it around evenly. All right, we got to pull that nut. See if we can do that. Well, lucky guess. Well, the nut on there, if I can read my socket, is 15/16. It's probably going to be loud, guys, so watch your ears. That electric impact, I tell you what, saved my butt a bunch of times. Oh, I did not expect that to come off that easy. But I'm happy it did. Nice. All right, we're going to hold it in there just like that, I suppose. That should let either side move freely from each other. Well, I guess it was coming off the way I thought it was. All right, well, there's the stator. And then your 3 phases come off right here. These went to the voltage regulator, which was all external, which was really nice because on my other one, it was all internal. So I really had to do a lot of work inside. Yeah. And we're going to make it a permanent magnet alternator, so the brushes won't be playing a factor in anything, so we had to get rid of those because I wanted to put out more than 12 volt too. So I'm going to see if this rotor will come out of here. I think it will. Doesn't appear to be moving yet. I might have to press it out of there. Don't want to break the housing though. Like I said, they're pretty fragile. Now, let's flip it up. Try and get it laying flat. Put the nut back on temporarily here, and we'll give it a couple whacks with a real hammer. See if get it to come out of that bearing. All right, now we're gonna give it a few swats and see if it comes out of there. Yeah, definitely moving. Oh, shaft's bottoming out on the vise here. Couple more. Gentle taps there. Just making sure them threads are clean before we go any further here. Coming off now, so just ran it on and off a few times just to make sure we cleaned up the threads, whatever did a little damage to them apparently. Set that back where it was. See if we can jiggle this out of here. Nope, it's gonna make us beat it the whole way, I suppose. All right, well, we're gonna lock it back in the vise here. We're gonna go rubber mallet for the rest of the way here. You guys still see all that? Okay. There she goes. Now you can see the claws I was talking about here. They look like claws anyways. So what I got to do now is press this claw off, get the copper coil out of there. So I'm going to press this apart, and then I will bring you guys back and we'll see how that goes. All right, well, you can see we got one half of the set of claws off there, and I marked it just so I knew how it went back together. I just put 2 on there and then colored the other one black that goes in between it. So there's a couple wires right here that connect for the electromagnet here, and we're going to cut those because we're not going to need that magnet anymore. We're putting a permanent magnet in there, so it's self-exciting. And yeah, so in theory, we're cruising right along here. We will see how difficult it is to get this out of here, this copper coil. All right, well, I had to cut this one too. I'm still not sure how I'm going to get that other piece that's pressed on off of there. But man, this is a massive chunk of copper. You can see how difficult it is to get it off. I cut it right in half, both sides. I'm still having a heck of a time. I was hoping it would, once it loosened up, it would just fall off, but not the case, man. It's on there very well. Now this is totally different than the one that I messed with before, but I keep saying that because it's completely different. Principles are the same. Construction is totally different. Now, when I first got into this, I thought it was going to be way easier, but it's proven to be quite a bit more difficult because I've still got that giant chunk of steel there to deal with. I got to get that off so I can get my magnets in place. But first, we got to get this out of here. So, job 1, get this out. Job 2, figure out, look at that massive chunk of copper, man. I'm probably going to hold on to that, melt that down, and make my own bus bars or something. I don't know. I don't want to throw all that copper away. It's expensive. So now we got to see if we can get this off. This big chunk of steel that was holding the electromagnetic coil there. So I'm going to deal with that because I don't have a plan for that yet. So I'll bring you back once I come up with an idea or it's off of there. All right, well, what I did was put a few welds on the outer perimeter of it and then air hammered it with a chisel bit. That's how I ended up getting it off there, because I couldn't get press in there, I couldn't get a puller in there, couldn't get anything in there. So I'm gonna thread it out of the nut here. Maybe. Straightened up, sure. I put the nut on there to protect the threads, but just working the threads to make sure we can get that nut back on. There's that. Okay, well, I did another variation here. This is kind of how I did it the first time. But you can see they're marked north, south, north, south. What I ended up doing was cutting those ears completely off. I expanded up a piece of my exhaust pipe, and that's what's actually keeping the distance in between. Now I do have to, because they're sticking up slightly, I double stack the magnets to give us a more, you know, to get it closer to the stator basically, and it'll probably have a much more dramatic magnetic effect. Now I don't know if this is going to work, but I've epoxied them in, so, and this is marine, JB Weld marine epoxy. I don't know if it'll work any better than, I tried super glue last time, I tried hot glue, I tried every kind of glue I had laying around, and I had this laying around, so hopefully this will work. So yeah, now what I'm going to do is take it over to my chop saw, because that's basically what I use as a lathe, because I don't own a lathe. And I'm just going to grind everything flush with the edge of these. So that should be nice and true, because it's sticking up slightly here and there, and I don't want it to hit my stator and do any damage to that. So, and I've also, since my first failed attempts, I added just the wires off of the 3-phase, and I still need to heat shrink this and everything, but I'm still in testing, so no big deal there. So and then we're using this full bridge rectifier. This is rated for 100 amps and 60 volts. Oh, 1600 volts. Nice. So not that we're going to make that much, but always nice to have a little headroom, I guess you'd call it. So yeah, I'm going to do that off camera. And then once I get it all ground down, I'll bring you back and we'll get this thing back together and do some testing. All right, well, I machined it down with the chop saw. Not recommended. Magnets don't like heat. This one, I don't know if there was a crack in it or what, but it's got a crack in it now, so shouldn't affect it. Well, I hope not. But anyways, yeah, not pretty by any means, but hopefully we get what we're after here. So I'm going to get this thing back together. You don't need to watch that again. I mean, you've seen me take it apart and put it together several times here, so I'm going to do that, and then we'll get it hooked up and do some testing. All right, well, we had some unfortunate things happen. Magnets do not like to be warmed up at all. I was grinding on there and had one crack, and then my glue wasn't holding and all kinds of things. So several hours later, I'm back. I got it put back together. It does have some cogging. It's not bad once you get it rolling, but man, initial torque would be quite a bit, I think. It spins pretty good. It's definitely got some cogging. And you can hear it even. It's so strong, man, those magnets. Those magnets are definitely strong. Now I've got the meter set to AC, and we'll just stick them on here and hopefully they'll stay for a minute. We'll spin it up and see what we can get power-wise out of this bad boy. Well, they're not going to stay on there. All right, let me twist them on there with my hands, I guess, with my fingers without gloves. See if we can get them to stay. That one appears to be on there, decent. All right, I've got to hook the 2 phases of the alternator here. And it's on AC volts. Can you see that? No, you cannot. All right, I'm gonna spin it up and we'll see what we got. About 9 volts AC. All right, I'm gonna hook it. I already tested all 3 and it's the same across all 3. So I'm gonna hook it to the rectifier and then I'll bring you back for a DC reading. All right, I'm just gonna hold these probes on here. I've got all 3 wires hooked to the 3 phases of the rectifier. And then I'll hold this dry. Got a lot going on here. But just to test here, you can see that fairly well. All right, we're gonna spin it up. And this drill probably only spins about 200 or 300 RPM. I don't even know, so. But we're getting, let me put it on lower setting. I got it on 200 volts DC because I wasn't sure what it was gonna make. Well, a little over 12 volts. A little over 12 volts with a drill. So I think once we, and that might not even be accurate because this might be, I might be losing a phase. Let me try it again. Yeah, I got too much stuff going on with all these wires. All right, I think they're kind of in there. All right, and I don't know why it's reading like 1/2 volt right now, or 5/100, whatever it is, 1/10 of a volt. All right, here we go. Yeah, so a little over 12 volts, man. Not too bad. So we'll continue on with this. It's got some cogging, but I think that little diesel motor will definitely be able to handle that. So